Hey, how are you?
Good. How are you?
I'm good. So, okay, so tell me, like, when are you taking your test? How are you doing with your studying and stuff like that?
Yeah, so the test registration dates haven't been released yet,
Okay,
but I'm going to take it in January on the 14th. So it's like the first test date of the cycle.
okay.
Um, yeah, I've taken it twice before. Haven't done as well as I want to.
How
So
did you
this will
do
be
on
my
those?
turn. Huh?
How did you do those first two times?
Got a 495 both times.
495 both times. And what was the score breakdown?
Oh, I don't have it on me.
Or, like, if you just remember, like, how you did relatively speaking, like, what was your highest section,
Oh,
lowest?
sure. Highest was psych, and then bio, and then cars and chem was like around the same.
Okay. Um, are you like a bio major or something?
No, I think I've always gravitated towards bio,
Yeah.
so it
What's your
comes
major?
in sequence. Well, I graduated college last year, so I'm in grad school right now.
Okay. What did you what did you major in?
Health sciences.
Okay. And what are you like doing a master's in public health or something?
It's in biomedical sciences.
Okay. Um all right. So okay. What material have you been using?
Yeah, the first time I used strictly all AAMC material. The second time I still use the same AAMC practice exams,
Mhm.
but I branched out of it and used next step practice exams as well.
Okay. How which next step full length did you do?
I did full lengths 1 through 6.
Okay. How'd you find those?
Just from like Reddit threads, people
I
normally
mean,
say
like
full length.
how did you find like the tests? Like
Oh,
not like sorry. Like how like were the tests?
I think they were pretty representative, though, like my actual MCAT scores were a little lower than my like practice exam scores.
Really? Okay. Yeah, because next step is usually is actually like harder than the AAMC stuff. So uh
I think my biggest downfall was the cars portion. It wasn't like
I usually
super
have students
representative.
just skip the car section for the next step exams. Um
Yeah.
but usually people have like when I did like a spreadsheet of people who scored in 100th percentile, um, their average scores for the AAMC tests were like around 524, but for the next step tests it was like 511.
Hmm.
So yeah, next step is really good practice for like CP and BP.
Okay.
All right, what else have you used?
Um, I mean, that's pretty much it.
Okay,
Just
when
those
was the
two.
last time you took the test?
In April, April.
Okay, April of 2021.
Hmm.
Okay. Okay, so how would you okay, you're in grad school right now. What's like your schedule like now? Like how do you want to like, schedule this out?
So I dropped my course load down to one class so I can focus on the MCAT more.
Okay.
Um, so I have that. And other than that, I'm also working on applications. Like my goal was to apply this cycle. So I'm hoping to take the January exam and apply to DO schools in January.
Okay.
Um, I'll be working on secondary essays on the side and like just like 1 to 2 hours of volunteering on the weekends. But
Okay.
my priority is the MCAT.
Yeah. Applications start in June, right?
Yeah.
Okay. So worst case scenario, you have at least until then, right?
Oh, no, no. So they started in June and then they end in like February, March for some DO schools.
Mm-hmm. I meant like a worst case scenario, like you have until like let's say you take it in January, or you don't feel prepared in January, you do have until June, right?
For the next cycle. Yeah, I have
Wait,
until
wait,
June.
because you already started your application like
Yeah,
this
I
past
wanted to,
June.
yeah, I started them
Oh,
in
got it, got
June
it, got it.
to apply
Okay,
like in June, but my MCAT didn't go the way I wanted it to.
yeah,
So I'm still going to apply to DO schools in January for this cycle.
I see, I see, and okay, so that means that you already started your application process in June of this year.
Yeah, so most of it's done.
Okay,
I just need to do my secondary essays.
I got it. Okay, okay.
Yeah.
All right. So okay, how would you like to begin?
Um, I guess my weakest points are still like chem phys and cars. So I guess it'd be ideal to begin with them.
Sure.
Um, yeah. And I can
Yeah.
probably dedicate like a solid 6 hours, maybe 7 hours a day, like 6 days a week to the MCAT. Do you think that's okay for now?
Yeah, I think that's a good target, like 6 hours a day. It doesn't have to be every day, but also if you can like when you start studying, start like a stopwatch, like just Google stopwatch and start that.
Okay.
And whenever you like take a break or go to the bathroom or like whatever, do anything, just pause it. And each day, I'll send you like a spreadsheet like that. I send my students to like for them to like have like a daily like regimen, like a ritual. But in that, you can input like the amount of hours that you've studied for that day, and you know, the idea is just that you have like just that that you've done 6 hours, or that you've done like whatever amount of hours, instead of like if you didn't do the stopwatch, you would just have a vague idea of like if you don't have any class, or if you just give yourself the entire day to study, you don't know how much of that you've actually spent studying. So that is something that you can do. Um, so okay, how are you with? Okay, so I'm guessing since you took it in April, you haven't done any like MCAT work since then, right?
No, not really. I
Okay.
like still have my grad classes, so I feel like my bio is still pretty solid because of them.
Yeah.
But other than that, not really.
Okay. So let's see. We can just like dive into like a section or something if you want.
Oh, okay, yeah, sure.
All right. What do you want to? What do you want to?
Um, I guess, um, I guess cars.
Okay. So for cars, we can use just because like AAMC cars is the most like representative of like the cars on the actual test. We can use cars like the cars question pack. Like there's two of those. There's a new like diagnostic thing that one of my students got, so that might be a good thing to start off with, or to use. But I think you would have to buy it because it's new. Um,
Okay.
but yeah, there's that, and also for CP, we can go over CP. But we can use like anything for that. We can use AAMC. We can use Next Step for that. So, okay, let's see. You said your Next Step exam scores were higher than your.
Mm-hmm.
Okay, one sec. Here, I'm gonna share my screen for a sec. I'll show you like the spreadsheet that I'm talking about. Okay, you can see this, right?
Yeah.
Okay. So, all right. So this is like for one of my students, and so this is called a Gaunt chart, and essentially so like for this student, I have him start off with the section banks. You've done the section banks, I'm guessing.
I did them the first time around.
Okay. Um, yeah. So those are good. So like I have him do like BB section bank, CP section bank, Psych section bank, cars question packs, then have him start the next step exams. So these are the 6. Now, since you've done the 6, I mean, like, how's your like budget when it comes to getting more like MCAT material?
It's pretty flexible.
Okay, because I think next step has like a total of 10 exams.
Mm-hmm.
So there's like 4 more that you can get. And then there's Altius as well. Which I hear is like pretty much like next step in the sense that it's like going to be like a little bit more tougher than the AAMC, at least when it comes to like CP and BB. There's also UWorld. They don't have like full lengths, but you can kind of like choose a topic or a section, and it'll like create like a number of like questions for you.
Mm-hmm.
And yeah, then I have my student like last do like the practice exams. This is the daily pace thing. So oh yeah, so he was like doing like a job search. So I guess he just updated this right here. But for example, like you'd put your like the date here, and the daily goal I say is like 6 hours. These are hours, by the way. And there's like a target, and you would just input that into the hours studied, and it'll automatically start to update in this graph over here. Let's see if I can find one for another student, because I don't want to mess this one up. Here, so like this student, and for status you can write down what you did like that day.
Okay.
And so see this chart over here. So like the target is just this diagonal red line over here, and the blue line is like the daily goal, and your progress is going to be the green one. So this will automatically like populate.
Okay.
Yeah, and then here you would put your practice test results, and that will also be charted.
Okay.
So for you, we can like put in what you got for like the next step exams and your AAMC like practice test and the actual like MCAT that you took. And then I have like the section bank and question pack scores, and then here's like some other like ways to kind of measure your progress. So okay, so let's see. Can you log into your like AAMC account and your next step account, and I can make a copy of this for you. So I'll call it MCAT Priya, right?
Yeah.
Okay. All right, so you got 495 both times on the actual test. Okay.
Do you want me to read you the score breakdown?
Yeah. So what is this for?
This is my AAMC account.
Okay. So
Okay.
yeah.
So with Chem Phys, it
Oh,
was a 124.
which test is this?
This is my actual MCAT, the first
Okay.
one.
All right. Yeah. Chem Phys was what?
124.
Okay.
Cars was 122.
Okay.
Bio was 124.
All right.
And Psych was 125.
Okay.
Okay, and then second time around it was Chem was 122.
Okay.
Cars was 123.
All right.
Bio was 125.
Okay.
And Psych was 125.
Okay. All right. Now, what about like your like the sample test, the full lengths, the AMC full lengths?
Oh yeah.
Oh crap! I wait. Sorry. I updated this in the wrong in the wrong person's thing. Hold on. Okay, fixed it.
Okay. Sorry, I'm just looking for the order that I took the exams in.
Mm-hmm.
Okay, so for the second time around, I started with a half length, actually through Altius.
Oh, you have Altius too?
Yeah, so I think that was the only one I took from them, the half length.
Okay.
And I got a 500.
All right, nice.
And then I took a next step full length 3.
Oh, can you give me the breakdown for that half length?
Oh yeah. For
I'm
the
just
half
putting everything in
length,
the spreadsheet.
for chem, I got a 122.
Mhm.
Cars was 122.
Mm-hmm.
Bio was 123, and Psych was 127.
Okay.
And then I took the next step full length 3, and I got a. Oh, that's weird. I didn't calculate it out. But chem was 125. Cars was 124. Bio was 125, and Psych was 127.
Wow.
Yeah, I don't know why I didn't put the score. And then for
501.
Okay. Let me write that down. And then I took the next step full length 3, and I got a 503. Chem was 126. Cars was 125.
Wait, sorry, say that again? Oh, which test is this?
This is next step, full length 4.
Okay.
Chem was 126. Cars was 125. Bio was 125. And psych was 127.
Okay, you are certainly improving.
Yeah. And then I went down a bit on next step, full length 5.
Mm-hmm.
Or actually, this was the Altius full length 5.
Wait, you went from the Altius half length to the full length 5? Okay.
Yeah, that's what it looks like. Yeah, and my score went down to 497.
Okay.
I got 123 in chem, 123 in cars, 125 in bio, and 126 in psych. Yeah, and then I went to next step, full length 6.
Okay.
And I got a 503. I got a 126 in chem, a 125 in cars, a 125 in bio, and a 127 in psych. And then I went back and did the AAMC full length 2, and I got a 504, and I got a 127 in chem, a 123 in cars, a 126 in bio, and a 128 in psych.
Sorry, 126 in bio and
a 128 in psych.
Okay.
But I think this was inflated because I already saw it once before, so this is my second time taking it. And then I took the sample test last for AMC again, and I got a 506, but once again, I think it was inflated. I got a 124 in chem, a 127 in cars, a 125 in bio, and a 130 in psych.
Nice.
Yeah. So this was my second time around. So I actually skipped around a bit. I didn't take all the full lengths.
Okay. That's all right. That's good. That means that we have material that we can work on. All right. So let's see. I'm gonna rearrange this so it goes in order because I started writing numbers here to kind of indicate order. But here, let me move some stuff around here. I'm just gonna move that there. All right, so it's going to be that, this, that, that, okay, so you can, all right, so yeah, you can see my screen, and let's see if I can make this so it's not as like confusing to look at. Let's see. Nope, not that. Okay, so wait. Okay, so there's a lot of like sorry, like this kind of looks a little messy, but oh wait, no, I have to get rid of these. Sorry. Okay, that looks better, right?
Mm-hmm.
Okay, so purple is your overall score, and 495, 490, and this is in order at which you took it.
Mm-hmm.
So 495, 495, 500, 501, 503, a 495, but it's Altius, so there's going to be some variability here. 503, 504, 506. So overall, you're improving.
Mm-hmm.
Now, that's overall. If we look at Chem Phys, it seems like there's a dip from the first between the first test that you took and the second test that you took, and it went up after that. Kind of like fluctuates a little bit.
Mm-hmm.
Cars seems to overall be going up though. That's this orange over here.
Mm-hmm.
So that's overall going up. Biochem seems to be like the most. Biochem seems to be around like the same range over here, and Psych Soc continues to go up. You're probably going to maximize that as you do that. I wonder if I could just make charts for the individual ones. Insert chart. Chem Phys. Let's do a line, or rather, maybe like a scatter plot or something. Alright, actually forget that. Here, let me do this. Average, whoops. Average. Okay, so your average, these are your averages for each of the sections. And so that's 120. Oh, I shouldn't chart this, but whatever. I'll change that. Yeah, your average for CP is 124.33 repeating. Cars 123.778. 124.77 repeating. Psych Soc 126. Average is like 500, and it's like an upward trend over here. So, all right. And I also see that your car score most recently was pretty high.
Mm-hmm.
Okay.
It was also from the sample test, like my highest. Yeah, I guess that is my highest, but it was from a sample test that I took once before. So I want to say that had some effect on me taking it again, and maybe that's why.
Yeah, I mean it's hard to, I guess, determine how much taking it before, like, because you took it before, like, how long ago? Like a year or something?
No, the first time was end of September, and then the second time was like beginning of April. So not even a year.
Okay. Yeah, because lots of people, obviously retake the AAMC full lengths, and surprisingly, a lot of times they don't remember exactly like what the answers are, and even if they do, there's going to be like some proactive interference, so they might, have a higher chance of getting it wrong. So, okay. So, okay, how many of the Altius tests do you have?
Those were the only two I purchased.
Okay.
So yes, that's it. Yeah.
All right. Okay, and the other AMC full lengths, you haven't done?
So this was my full length schedule from the second time around. The first time around, I took them all. Let's see.
Okay.
Do you want the scores for them?
This is fine. The second time around stuff is fine. Here, I'm just going to separate these by section so it doesn't it doesn't have everything on the same thing. Oops. Wait, let me add some labels. I'll add a trend line. Well, let's make that like that color. Okay, so here's just cars and here's just Chem Phys. And let's see. Yeah, the overall Okay, so I'm guessing you went you went over these tests, right?
Mm-hmm.
Okay.
Yeah.
So maybe we can start like either a new one. I mean, like, unless you feel like you would be wasting it. What do you think?
Like for practicing right now?
Mm-hmm.
I don't mind starting a new one.
Okay. Let's see. Do you want to do a next step test?
Sure, yeah.
Okay. All right. I'll let you share your screen.
Oh, okay. Should I just pick, I'll just go with cars, right? That's fine.
Oh wait, if
For
you want to do cars, we should do AMC cars.
Okay.
But we can do like a CP one. I just want to get an idea for like what topics in CP that you tend to have trouble with.
Okay.
So we can do that, and then we can do some like AMC cars like right after. Okay, how does that sound?
Okay. Sounds good.
Okay.
Okay, share screen. Are you able to see that?
Mm-hmm.
Okay.
What is okay. Which test is this?
I just went with the last one, number 10.
Oh, okay. So you have all 10.
Yeah, I bought them. I just didn't use all of them.
Got it. Got it. Okay. So so what I recommend when you're doing these tests is to is to start off with the questions, attack the questions first, and also to start with the discretes.
Okay.
Because the discretes are basically, you can answer them super, super quickly. And if you do the discretes first, then that's already like more than 3/4 of the test done. So then when you return to the passage-based ones, you're going to have that additional like level of confidence.
Okay.
Now, this is what I would do. So hit like navigation, or you can try this. Try wait, maybe, well, okay, I forgot like the exact keyboard shortcut, but yeah. So hit navigation and go to like maybe like 14, question 14. Okay. So now go to previous. I went too far. All right. go back to like 10. Yeah. Okay. So let's start off with the discretes, okay? And generally speaking, how are you with like timing?
I constantly feel like I'm running out of time for Chem
Yeah.
Phys.
Mm-hmm.
Yeah.
Okay, so let's try this. So a stationary charge lies to the right of a current carrying loop of wire as depicted in the figure below. Arrows indicate the current. While the current is flowing, the charge will, like what, essentially. So yeah, what are your thoughts on this?
Current, the charge will. I feel like there was like a little, like a hand mnemonic. I was taught for this for
Like a
like
right hand
which way
rule
to
or the curl?
right hand rule.
Mm-hmm.
Yes. I'm just trying to remember which way to orient it. It's depicted below. Charge will move out of the page at a constant speed, accelerate into the page motion. Accelerate out of the page. I want to say it's A or C.
What do you think about B or D?
I don't see why it would remain motionless.
Mm-hmm.
And from what I remember, charges do accelerate, which is why I want to say A or C. I just don't remember the orientation to pick whether it's going out of the page or into the page.
Okay. So, all right. Okay. So there's two things going on here. So one, a magnetic field is being created, right?
Mm-hmm.
And doing that, you can use like the curl kind of rule. Like essentially, like if the current is going in this direction, it'll curl like around. So here, let me go to annotate. So
Okay.
I forgot exactly if like X meant into or out of. Do you remember?
I think X was into.
Okay. So here will be out of, that would be into, right? Can you see that?
Yeah.
And then as you go like here, it's going to be out of here. Oh wait. X is into, you said. All right.
Mm-hmm.
So out of into, right?
Mm-hmm.
Now, that's going to be magnetic field. And then there's like the other right-hand rule, which is kind of like this. It's just essentially like three vectors that are all 90 degrees from one another.
Mm-hmm.
And so essentially, like, one of them will be like the velocity, I suppose, of the charge. The other one is going to be the magnetic field, and then the last one will be the force that's caused, and that force one is what we're going to be thinking about. Now, since force causes an acceleration, like, this should not be our answer.
Mm-hmm.
So it's either going to be accelerating like out of the page or into the page, or it could just simply remain motionless, like as if the magnetic field doesn't affect the charged particle. So also another thing with these tests is also for timing is if anything like takes longer than like a few seconds, flag it and move on.
Okay.
And if you're not 100% certain about a problem, I would also say to flag it and move on. So let's try that here. So why don't you pick whatever you think it's going to be, and we can flag it.
Okay.
All right. Yep. And then let's go on to the next one. All right. Now this. So what do you think about this?
While solving chemistry problem, student uses equation. Following must be true. Well, the reaction is definitely spontaneous, and so it is also exothermic.
All right. Let's start with just so we know for certain that it's spontaneous, right?
Yeah.
So what can we get rid of? Which choices?
B and...
So far, just B.
Yeah.
Right? Okay. Now, they're saying must be true. So, we don't necessarily know if it's going to be exothermic or if the entropy is going to rise, right?
Okay.
I mean, what are you thinking?
I thought it was exothermic because the G is negative. If it was positive, it would be endothermic. Right?
But so exothermic and endothermic deal with enthalpy, which is heat energy. Are you thinking of endergonic or exergonic?
Oh, I am.
Mm-hmm,
Okay.
Mm-hmm. Yeah. So exothermic and endothermic refer to that, and entropy is, delta S.
Okay.
Do you remember how they all tie together?
G equals enthalpy minus temperature times entropy.
Mm-hmm. Yeah. So okay, let's say it is exothermic, then this thing will be negative. And if it increases entropy, delta S is going to be negative or positive?
Should be positive.
Okay, so that would be a negative minus a positive, which will be essentially that positive value minus... Oh, then they would all add up. So we can't really know for certain... whatever it's... we can't know for certain if it's exothermic or if it's going to increase entropy or not. But let's do the same thing that we did before, which is like, choose like our best answer, flag, and move on. Because the strategy here is essentially that we're going to see all of the problems and have like 10-15 minutes left, and then you can choose which problems or which passages to spend your time on, because not every passage or not every question is going to be the same difficulty, right? But they're all worth the same point.
Okay.
So, did you hit flag?
I did.
Okay, cool. All right, let's do that one. All right.
Is I actually don't remember what amphiprotic means.
Yeah, no one does, but because they never talked about it. So a lot of times the MCAT is going to throw things at you that you don't know, but you can still kind of figure it out. Like, what do you know that starts with amphi?
Amphipathic.
So what does that mean?
I think it's when a molecule is both polar and nonpolar.
Okay.
Or hydrophobic and hydrophilic. It's one of those.
All right. What about amphoteric?
I don't remember.
What about amphibian?
Yeah, like a frog.
An
amphibian. Okay.
Like, show me how that connects.
Like they can be in the water, but they can also be out of the water.
Exactly. So now you essentially know what the amphi part is, right?
Okay.
And now the protic part.
Like water loving.
Well, like think of like proton.
Okay.
All right.
Okay.
So yeah. Now, what do you think? Okay. Go on. What do you think from there?
I'm looking for a proton in my molecule.
Okay. So we can cross some choices out, right?
Yeah, A and C.
All right.
I want to say it's B, but I don't have like a definite reasoning.
I think you do. Just why do you think it's B?
It's a charged molecule that has...
Well, remember the amphi part? So, okay. H3PO4, what can it do with its proton?
It can dissociate.
Okay, it can give it away, right?
Uh-huh.
But can it get more?
No.
All right. What about HPO4 2 minus?
It can give it away.
And it can also?
You can also take it back.
Yep.
Okay.
So, yeah, remember that this test is a critical thinking test. So, basically put on your thinking cap, because, like, what you said, like, I don't remember this, no one does. Like, it's designed that way. It's designed to take, like, things that you know, and, through certain leaps of, like, insight, you can figure out what it could be from there.
Okay.
Yeah. All right, aldol condensation. So No one really remembers this. I don't know. Maybe you do.
I do not.
Okay. Well, condensation typically means what in terms of like like orgo, I suppose.
Taking two molecules and combining them.
Mm-hmm. Yep. So so we're basically. Oh wait, A is that top one? Okay. All right, so let's, I guess, look through the choices here. Okay, so how can you describe these choices?
Well, this is an aldehyde.
There's also a ketone in there, right?
There's a ketone, yeah, and then there's just a ketone here.
Mm-hmm. So an oxygen leaves, right?
Mm-hmm.
Okay.
And then these only have one molecules each. Another ketone, a couple ketones, an alcohol, ketone.
Yeah. So I see the first two options see like they only have just one oxygen, right?
The first two options.
Mm-hmm.
Mm-hmm.
And then the last two, the oxygens stay, right?
Mm-hmm.
Now, which one are you leaning towards?
I honestly still don't know.
Let's see. I mean, in a typical, so like, let's say it's just a regular condensation reaction. What is that also known as?
I can't remember.
Something synthesis. Something involving water. Like if you had like something like this and something like that. Whoops. Like dehydration synthesis.
Okay.
So that's the same thing as a condensation reaction.
Okay.
So, and it's called that because you are, a water is like produced, like a water leaves.
Mm-hmm.
So you can have like maybe like an OH group and like maybe like, whoops. This could be like, between something like and whatever. Something like this, right? And essentially see how that makes an H2O.
Mm-hmm.
And then this is like a peptide bond, right? What I'm drawing at least.
Yeah.
Okay. So this is also a condensation reaction, so I would believe that a water leaves, right?
Mm-hmm.
So in order for water to leave, one of the oxygens have to leave, right?
Right.
So right away we can cross out half of the choices, right?
Mm-hmm.
Like we can cross out which ones, like
Would you be able to cross out A and B?
So in a condensation reaction, right? An H2O is produced and leaves, right?
Mm-hmm.
So that means from the original reactant, it's going to lose like two H's and an oxygen.
Okay, well, so it has to be C and D.
Well, it'll have to lose an oxygen though, right?
Mm-hmm.
So it can't be C and D, right?
Okay.
Because they like just like in this example, like this turns into like this is a like a peptide bond, right? Because essentially like what I wrote in the red box, that OH from the carboxylic, yeah, and then the H from the amine of a different amino acid, they get lost and then a bond is formed there, right? So this one has, like, these both have that oxygen there, and it has to lose one of the oxygens in order for it to produce like an H2O. Right?
Oh.
Okay. Yeah, so remember that condensation reaction is dehydration synthesis, okay?
Okay.
Alright, so C and D are out. So let's take a closer look at A and B. Alright, so we have essentially... So what we're seeing here is like a ring closure, right? Or like, a ring formation, right?
Mm-hmm.
So basically a bond is being produced, from here to there, right? So that's
right.
why, yeah, so, and this is 1, 2, 3, 4. And I think the one that loses the oxygen will be the additional one, like the additional like carbon to make it the 5, the pentose like kind of ring, or the pentane ring. But here, and then we have on the outside 1, 2, and 3. 1, 2. Oh, okay. Actually, so it's going to add like. It's going to basically add, I think, something like that, maybe. So that explains, these two carbons and these two carbons, right?
Mm-hmm.
All right. Yeah.
Yeah.
Okay. So, let's see. Okay, so essentially we have this like weird double bond that's all the way on the outside there, which I don't know, it's kind of weird. I mean, let me just see if it even checks out. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, that checks out. No, it doesn't check out. The carbons don't check out. There's 7 carbons there, right? And then this has 8.
Oh, right, because of this one here.
Yep. So that's
Okay.
out. And right away, like, it looks weird because you don't really want like a double bond to be all the way. Yeah, there's several reasons that this can't be it, because I mean, a double bond is going to be planar, right? And it won't be, yeah, that won't really, like, because you have something, a planar molecule there, and then a double bond to this. I don't think that would work. It would be more like this, something like that.
Right, because a double bond would form to make the most amount of connections.
Mm-hmm.
Right, it wants the most amount of bonds. So
yeah,
this would make more sense than this one.
yeah, and I think like so I would put like B, I suppose.
Okay.
So this is just an example of us, like, we don't remember exactly what the aldol condensation like really like does, but we know condensation means dehydration synthesis, which means the loss of H2O. So we narrowed it down to 50-50 right away, because two of the choices have two oxygens in it, which can't be. This I think C over there, I think, is like the intermediate step. And I think what happens with, well, wait, 5, 6, 7, 8. So okay, it would be the intermediate step if that wasn't there. But I'm sorry, yeah, because that one also has too many carbons. But like that intermediate step is usually going to involve like that OH that can just be protonated and turn into like H2O, which is a good leaving group, and leave. Then it would create that double bond here. Like this can be H2O here, and it can leave, and then this thing would go there.
Mm-hmm.
Yeah. So. Yeah, another thing I do with my students is like just show them that there's so many ways to determine what the right answer is, like based on how wrong the other answers are.
Okay.
Like we determined that like C and D can't be it because there's an extra oxygen there, and we determined that A couldn't be it because there was an extra, or was it B? I forgot. The other one couldn't be it because there was an extra carbon, right?
Mm-hmm.
Okay. Alright, so now we're going to do this. We're going to go to the next set. So, I mean, I have this written down somewhere, so I don't have them memorized, but let's see. If it was 10, I mean, maybe it would be like 22 or something.
Okay.
Like, for the actual test, you're going to have it, like, memorized. Okay, so go back. So I think I overshot it again. Oh, damn it. Okay, so maybe it's after.
Okay.
If you do, like, Alt N, I think, you can go, like, pretty quickly through the... Yeah, okay, yeah.
Oh, okay.
Yeah, alright. So how are you with, like, the physics stuff?
The stuff that I know I'm really good at, but there's still certain topics like optics that I struggle with.
Okay. There's like a Reddit post that I made on optics. I'm not sure if you've seen it, but I'll like send that to you because I also relate it to like vision.
Okay.
But okay, so let's see. Object weighs 150 grams in air, but 75 grams when fully submerged in water, and 60 grams when fully submerged in an unknown fluid. Okay? What can be concluded about the specific gravity of the unknown fluid and the order of layers when water is mixed with the unknown fluid, assuming that the unknown fluid is immiscible in water? So, this is a great example of like another tactic that I use, like where like where we look at, because each of these choices have like a first part of the answer and a second part of the answer, right?
Mm-hmm.
So the first part is talking about a specific gravity, which is going to involve some math. But before we do that, we can answer the second part, which is, the order of layers, right?
Mm-hmm.
So, okay, so let's see. So if something is, all right, so why does it weigh? Oh, that's funny. So that's actually, I don't think that's supposed to be grams. I think it's supposed to be, wait, no, that doesn't make sense. Like G? Whatever. Because gram is like for mass. But anyway, it could mean like G, anyway, when something's submerged in water, would it weigh less?
I just remember from chemistry, water was always like the bottom layer when we mixed two fluids. It was always denser from our experiments.
I mean, it depends on what we're...
Like if it was nonpolar and polar, usually the polar stuff was on the bottom and the nonpolar stuff was on top.
Well, okay. So, like, polar and nonpolar won't mix. That's the immiscible part. Mm-hmm. But, it depends. You can't always say that water... I mean, mercury, for example, has a specific gravity of, like, 13. Which means it's 13 times more dense than water, right?
Okay.
Yeah, there's a lot of things that are denser than water, but think about it. So I wouldn't like use that as like a rule of thumb because it really depends, right? But when it's fully submerged in water, it weighs less. Now, why is that?
I don't know, but can we use that to say it'll be the top layer?
So, okay, because like we're going from like A to D, but let's do like the in-between steps, right?
Okay.
So, I mean, like, think about it's like you've been in like a pool, I'm guessing, right?
Mm-hmm.
All right. So when you're in a pool, right? Do you feel heavy, like relatively speaking, or like lighter?
You feel lighter.
Okay. Now, why? Yeah, why?
Buoyancy.
Yes. Buoyancy, because essentially, like, the air is the thing that's going to be under you if you're in air, and gases are compressible. So that's not going to really like cushion you too much. But liquids, fluids, they're incompressible. So that's going to be like cushioning you. So there's going to be some like a buoyant force that is going to be opposing the force of gravity. Right?
Okay. Mm-hmm.
So that's why, you're going to be like, what is this, like half the weight in water, right?
Mm-hmm.
Okay, and then when fully submerged in an unknown fluid, right, you weigh even less. Okay, now, do you remember anything about the buoyant force, like any, like...
Mm-hmm. Buoyancy, like the formula. Buoyancy is equal to density times volume times gravity.
Okay. Density of what?
Of the object, or the amount of water displaced, I guess.
I mean, but what if it's in different... What if it's not in water?
Then density of the object overall.
So it'll be... Since the object is the same, right? Whether it's in air or water or an unknown fluid. So it's going to be the density of the fluid.
Okay.
So like buoyant force is going to be the density of the fluid times the volume displaced
Okay.
by the object.
Okay.
Maybe I'll write like that. Times G, right?
Mhm.
Let me ask you this. Density times volume is what?
Mass.
Okay, so that makes sense because like mass, because the force of gravity then, right, is just the mass of the object times, G, right?
Mhm.
Okay. And they're opposing each other. And so okay. When it's in water, right? They're going to be essentially equivalent, which is why it's like half, right? But
Mhm.
when it's in the unknown fluid, it weighs even less. So okay, if I did something like this is the object, this is, the weight essentially. So that's just in air, right?
Mhm.
And FG, FB, so that's in water, where essentially they're like equivalent because it's like half essentially. It weighs
Okay.
half as much, right? And in the unknown fluid, however, the buoyant force, I'll say like, for the unknown, is greater than the weight of the object.
Okay.
All right.
Mhm.
So now, from what we know about, this, right?
Mhm.
So, between the buoyant force of all of these examples, 1, 2, and 3, the volume displaced is going to be the same, right? Because it's fully submerged and it's the same object.
Right.
And G is always the same, right?
Right.
So the only thing that's different is the density there, right?
Mhm.
So okay. If the buoyant force of the unknown fluid is greater, right? Wouldn't it mean that the density of that unknown fluid is greater?
It would.
Yeah. Okay. The denser the fluid is, like, in terms of what's on the bottom and what's on top, the one that's on top isn't always like the hydrophobic one or whatever. It's the least dense one.
Okay.
And that's the same for everything. I mean, hot air is less dense and that rises, right?
Mhm.
So okay, so we know that the unknown fluid is the most dense, right?
Right.
Okay, so that would be the top layer, right? Oh wait, sorry. I'm wrong. That'll be the lowest layer because it's the most dense.
Right.
So the water will be the top layer, right?
Right.
So these are gone. Like B and C?
Mhm.
Okay. Now, so this is what I was saying, like we can answer things based on the first part and the second part.
Mhm.
So we've handled the second part. We know water is the top layer. And now we just have to figure out its specific gravity. Now, specific gravity, like what do you remember that? Like so
Was there an equation for it?
it's just how it's related to the density of water. So like when I said before, like Mercury's specific gravity is 13, means that Mercury is 13 times as dense as water.
Okay.
Yeah. Now, all right. What do you think? Like, all right. What can you do from there?
Can we use the same formula that we were just talking about, or no?
We can use these values, but we can also just solve it using. Oh, okay, actually, we can't use it. You can't solve it using a qualitative way, because a lot of times you can. Because we know that since it's more dense, it's going to have a specific gravity greater than 1. But since both A and D have values greater than 1, we're going to have to actually see by how much, it changes.
Okay.
Now, okay, so essentially, the difference here is 15.
Mm-hmm.
And so I suppose 15, that's 4, that's 5. It changes by like a fifth, I believe. Let me see. 75, 60. Yeah. I think, okay, let's see. So if I did for water, where these things are the same, it would be this times that is equal to this times that. These are gone. And the mass, I don't know why it says weighs, but I guess they mean mass with a G. So I'll just do 75, grams. This thing, whatever V. So okay, that would be I guess the thing for. So okay, I should say it like this: unknown over H2O is the specific gravity. Right? Okay, so we know that the density of water is equal to 75 grams over whatever volume of that object. And then we can say for the unknown, it's going to be 60 grams over volume of object. And if we put it into that, like this formula on top, can you see my cursor? Wait, you can't because I'm not sharing it. But I would put it into this. Oops. Yeah, that equation up there. So that's essentially just going to be. Oh wait. So okay, it would basically just be 60, grams over 75 grams because the volume of the objects are the same. Then those cancel. And wait a sec. I think it's. Oh, sorry. It's one. It's the other way around. Sorry, it's the H2O one and wait, unknown. If it's denser, yeah, H2O over unknown. Hold on. If it's greater than 1, the density of the unknown should be on the top. But then I would get the weights, the masses. They would be different. Sorry.
It's okay. I was wondering if you could use a proportion
Yeah.
and just
Yeah.
like 75, 60 is equal to x over 1.
Wait. Sorry?
If you could just do like 75 over 60 is
Yeah,
equal
yeah.
to
That's
x over
what
1.
I was trying to do. I was trying to see like which one goes on top. And if I did H2O on top, then cuz at first I did the unknown on top and that would give me 60 over 75, which is less than 1.
Mm-hmm.
So it would have to be the H2O on top. But yeah, 15 goes into this 4 times, 5 times over here. And then that would be 4.2. Anyway, yeah, I just noticed like the difference is by a wait, what am I talking about? Sorry. Yeah. All right, wait. 15 goes into 60 4 times, goes into 75 5 times. 5 over 4 is 1 and 1 1/4. I mean, I'm pretty sure it's just going to be that. I think I'm messing up something here. I should have just done 5. 5
That's
goes
what
in.
I thought.
Yeah. I don't know why I chose 15. Yeah, essentially, okay, so 5 goes into this 12 times, 15 times. Oh, that's even messier. Anyway, I'm pretty sure it's this. How do you feel about that?
Yeah.
Just because
So-
when I first looked at it, I just noticed like a fifth being a thing. But yeah.
Okay. Sounds good.
Which of the following is most likely to be the enzyme labeled X in the figure below? Okay. So what's happening from glucose 6-phosphate to 6-phosphogluconate?
It's getting reduced.
Huh. They're so bad with like their typos here. Sorry, yeah. Mm-hmm.
And so then it's D.
Yeah, good job. Tell me about kinase.
That's when you are, uh, it's the opposite of phosphatase, which is where you remove a phosphate group. So kinase is when you add it.
Yeah, and I want you to know this. It's a little bit more specific, but a kinase, what it specifically does is, so it acts on these amino acids. Now,
Right.
what do these have in common?
They have a oxygen group as their R group.
Yeah, hydroxyl, like an OH?
Yeah.
Yeah.
An OH.
So whenever you see that, think of nucleophile, okay? And it nucleophilically attacks the gamma phosphate. So, all right, good. What about the mutase?
I'm pretty sure that's when one group is moved.
Yeah, like it's an isomerase essentially, right?
Yeah.
And then what about that?
It's when a carbon is cleaved off.
Yeah. I think like a CO2 comes out, but
Yeah.
yeah. Okay, good. So, yep, that's a D. Okay, so yeah, so this is asking about what ATP is essentially.
Um, well, it has a pentose sugar group, so it's gotta be A or B. Um, and it's a purine base.
Okay. Yep. Yeah, free radicals. So these are also known as ROS, reactive oxygen species.
Mm-hmm.
Okay. And, alright.
Um, I don't know which one to choose.
Alright, let's just take a look at them. NADH, does that... So, okay, let's just think about first, like, a free radical, right? Something like that.
Mm-hmm.
Like, unpaired electron.
Right.
Alright, how can you make that, not a free radical anymore?
You can either take away the electron or add another one.
Yeah. Okay. All right. I would say. Okay, we'll think about that now. All right. Like these two, how do they kind of differ?
Well, NADH can deliver that proton, and FAD can take in the proton.
Um. So these are like electron carriers, right?
Mm-hmm.
Now, FAD can transfer or carry like either like one or two electrons.
Right.
But NAD, that's only going to be with two electrons.
Mm-hmm.
And that H, by the way, is a hydride. It's a hydrogen with two electrons, so it's negatively charged.
Okay.
All right. So yeah, the NAD stuff that only can that only deals with like two electrons at a time. That's why it's usually like plus H plus, right?
Mm-hmm.
FAD, however, can give one electron. So that can. Oh yeah. Oh, and then I guess we should think about like since NADH is reduced, it can act as an oxidizing agent, causing this guy to like lose an electron, whereas FAD is the oxidized state, so it can as it gets reduced, it... Wait, what am I talking about? Sorry. NADH is reduced and gets oxidized to make NAD, and as it gets oxidized, it reduces the other thing, so it causes the other thing to gain electrons.
Right.
And FAD gets reduced, so it gains the electron. Okay. Vitamin E acts as a free radical. That one, just good to know. And then ubiquinone. That's the same thing as coenzyme Q, was it? Coenzyme Q? Yeah.
Right. I'm just trying to remember its form because it alternates between semi-ubiquinone and one other one. So I don't remember if it's the completely oxidized one.
Yeah. So, like, you know, I forgot how I wrote it. I think I wrote it like something like that or something. Because there's like two, like, essentially layers. Not layers. Here, one sec. Oh, yeah, I'm going to share with you... I'm going to share with you a lot of, like, material. But, wait, where did I write this stuff? Oh, metabolism. Oh, yeah, I wrote UQ. Yeah, UQ to UQH2. So I believe it's a 2 electron a thing, like reduction. So we have a couple of 2 electron ones, and we just have to determine which one is so okay, ubiquinone can turn into ubiquinol.
Okay, that's what it was.
Yeah. When it gets reduced. And so ubiquinone can get reduced, FAD can get reduced, and NADH would get oxidized. So I think it might be C. Because, I mean, FAD would get reduced, which means that it'll take an electron. And ubiquinone seems like it would take electrons too, right? NADH is the only one that should give electrons.
Right.
And it'll have to only give 2 electrons. I think that's going to be the one that kind of helps us. But I would choose whichever one you feel comfortable with and flag.
Okay.
You know, just yeah. Okay. Normally, I would say we would do more discretes, but let's do, like, you know, a passage-based one since we haven't
Okay.
done these. So, yeah, like, I would also, like, look through, like, the passages and see, like, which ones would give you, like which ones you think would give you, like, a harder time. So, like, you know, you can kind of, you know, look through them. Because the idea is, like, you know, you do the discretes first, and then you can do the passages based on how, like, comfortable you are with, like, you know, the material for the passages.
Okay.
So, like, yeah, so you said, like, optics is one of your weak points. Yeah. Yeah, how about that? This one.
This one?
Like, is this is like with like...
With currents?
Mm-hmm.
Uh, I was fairly good with them, but I haven't reviewed it in a while.
Okay, all
So,
right. Let's look for one where, that would be like something that would give you a real hard time.
okay.
Might as well.
Okay.
Sorry.
That's restored.
Actually, whatever. Let's do a passage.
Okay.
Yeah.
I guess this one's fine.
All right. Okay. So, based on the passage, if the initial uterine sac diameter is 6 millimeters before pregnancy, by what factor does the force acting on the uterine muscle increase between week 7 and week 10? So, okay. I would look at like figure 1, I suppose. All right, yeah, there we go. So they're talking about all right, so diameter is the y-axis, right? So if the initial one is initial diameter is 6 millimeters, something like here. It's kind of reached like around there, and that's before pregnancy, okay. And then between week 7 and 10. So uterine muscle. All right. So this is just talking about the gestational sac diameter, and it seems like we're going to have to determine that force, like how the force of the uterine muscle increases between this time span.
Mm-hmm.
And since figure 1 just tells us the diameter, we're going to use that and input it into that and solve for force, essentially, right?
Okay.
Yeah. So, we can see like a little bit below that. So they're talking about... Here, let me clear my drawings. Okay. Sphere, volume. Okay. See, all right. So okay. So before all right. So you see how it says V0 is the volume before pregnancy?
Mm-hmm.
Okay. And I'm just going to show you like a trick here. So this over here, pi, that's pi, right? You see that?
Mm-hmm.
So pi is essentially 3. So we can just get rid of those. Yeah. Whenever I show people that it blows their mind because they're, like that. It's like in the volume for like a cone, there's also like a 1/3, but the pi makes it cancel, so we don't have to be too concerned with that. So how about this? R0, I'll call it. What's that going to be? Not refers to before pregnancy.
The diameter before pregnancy?
Oh, like or radius r.
Oh, we're looking for the radius.
Oh, it's in the question.
Oh,
Stem.
so 3.
Okay. Now, v naught is just going to be 4 times 3 cubed. So, what's that?
Um, um, about 100, 108.
Mm-hmm. All right. So, all right. So we have that. Now, oh, they even like kind of wrote it out for us, but we don't need we don't need that. But now let's see. Delta V is a change in so the volume before delta V a change in volume. All right, so I'm just going to write R7, R10. So on the the 7th week, this is like whatever, like 21 or something like that, 22 something. So let's say like 11, right?
Mm-hmm.
And then this over here is like 44 or something, right?
Mm-hmm.
So like whatever, 22, right? Right. Okay. So the delta V. So the delta V is a change in volume. I'm trying to see. All right. Can you yeah, scroll down some more. I'm trying to see if the delta V is from before pregnant. Delta V is a change in volume. By what factor does the force acting on the uterine muscle increase between week 7 and week 10? You know what? Hold on, let me see something. Area, surface area of the uterine lumen. K is the bulk modulus. Doubles. Increases by a factor of 8. Sorry. Okay. Let's see. 2 equations. R3 minus that. Volume before pregnancy. Change in volume. Okay, I was trying to see if the delta V is going to be related, is going to be like the difference between how it was before pregnancy and then the next thing, but I think delta V is just going to be between week 7 and 10. So delta V is essentially going to be, let's see, 4 times 11 cubed minus 4 times 22 cubed. I'm going to just pull that 4 out. There must be, wait, there has to be a faster way of doing this. R naught. Oh, okay, wait, they're using... Huh? Meters. 11. Alright, I'm going to use easier numbers here. And by the way, if you have any questions or ideas, feel free.
Okay.
Can you see that the top of this passage?
Mm-hmm.
Okay. And scroll down a bit.
Do you want to go all the way down?
Oh yeah, sure.
This is it.
Okay. I'm trying to see. Oh wait, what's up? Oh, I thought you were trying to show me something. A is the surface area of the uterine lumen. K is the bulk modulus. By what factor does the force? Did I? Oh yeah. Okay. So, I mean, from the radius seems to like double, which would cause the volume to increase by a factor of 8, like 2 cubed. So now, that makes sense here. R3, R cubed, change in volume, factor of 8. Uterine lumen. Okay, I need to. I think. Okay. Force of the muscle pushing out. A is the surface area of the uterine lumen. Surface area of the uterine lumen. K is the bulk modulus. Volume before pregnancy, change in volume. Uterus can be modeled as a sphere. With that, using this, delta V over that can be expressed as this. Outward pressure on the muscle is opposed by the elastic recoil. There are outliers. Uterine sac diameter. Yeah, what do you think?
I don't know. I also plugged in the numbers 22 and 11 again into this equation.
Yeah.
But the numbers are huge. So I don't know. If I was doing this on test day, it would take me forever.
Yeah, okay, let me see if I can make this. So delta V is equal to R cubed minus R naught cubed over R naught cubed times V naught. Okay. Well, what did you plug in for R?
So for R, I plugged in 22, and then I did 11 for R naught.
Okay, because I was thinking R naught would be that for V naught, but all right, that makes more sense. So let me try that then. Um, okay. Scroll up a little bit.
Mm-hmm.
All right, I think okay, this is 2 to the 4th, 2 to the 5th, nothing. 2 to the 6th would be 64, 2 to the 7th would be 128, 2 to the 8th would be 256. 2 to the 9th, 512. The 54 part, where does that come in? Area. Okay, let's choose something and flag it.
Okay.
And sometimes as we go through like the rest of the questions in the passage, certain things will make more sense. Abnormally low gestational sac volume in participant 3. Okay. So they'll be like, on the bottom of this.
Sorry.
Okay. Small gestational sac diameter. Additional finding, high pressure. Okay, and that's talking about the outward pressure on the muscle, I believe. High pressure compared to normal. Is there anything on that right side? Oh, yeah. Okay. So I see differences in amniotic fluid production and high pressure compared to normal for given volume. Okay. Abnormally low. Okay. Okay. So I think if we look at that first kind of equation, that's something like this.
Mm-hmm.
It seems that Okay, so the K, so like, let's see, what would K... So F is the muscle... Sorry. Respond force to equations. F is the force pushing the muscle out. A is the surface area of the uterine lumen. K is the bulk modulus, which functions similarly to the spring constant of the muscle. Okay. And volume before pregnancy, change in the volume. Okay. Model does a sphere. That. This thing over here. Alright. We could do this in a couple of ways, it seems. Like, there's like three kind of things in each of the choices. Like, the type of mutation, whether K is going to be low or high, and if it's going to act on the smooth muscle or the skeletal muscle. So we can actually answer this question from in a couple of different ways.
Well, since it's talking about uterus, would you assume it's the smooth muscle, not the skeletal muscle?
Good. Because skeletal muscle is can be consciously controlled.
Mm-hmm.
And I also saw like where it said, nonsense mutation.
Mm-hmm.
Okay. And then there's point mutation, frame shift mutation, which would mess a lot of things up. And then if it's going to be a low K or the high K.
If the volume is abnormally low.
Oh, can I see participant 3 again? I forgot to look at the phenotype.
Mm-hmm.
Okay, so that is small, right? And that's high.
Mm-hmm.
So the V naught. Sorry. Well, like this is equal to pressure, force over area, right?
Mm-hmm.
And it seems like then pressure is proportional to K, and pressure is inversely proportional to like the original volume.
Mm-hmm.
Now, small gestational sac diameter makes me think that it would have a small initial volume, which would mean a higher pressure, which would mean a higher
Mm-hmm.
K value. The high K value over here. Oh, okay, wait. So it says as the uterus expands, or rather, F is the force pushing the muscle out. A is the surface area of the uterine lumen. So I guess, okay, so the uterus lumen is like the overall like container almost.
Mm-hmm.
And then, the volume is referring to like the uterine like sac itself. And then F is the force that pushes it outwards. And I believe if K is a bulk modulus which functions similarly to the spring constant of the muscle, so like a spring constant, when you deal with whatever, like a spring, right? It functions. Yeah. Were you gonna say something?
Oh no, I'm just nodding along.
Okay. So they're saying as the uterus expands, right? The outward pressure on the muscle is opposed by the elastic recoil. So it's kind of like something like if this is the uterus, and F is the force pushing it outwards. This is being essentially opposed by that elastic recoil, which is essentially this bulk modulus thing, K. So, okay, so I think that, yeah, I mean, I'm going to be leaning towards a high K value then.
Okay.
Just because... Yeah, because I don't know how it'll affect the specific type of mutation. But a high K volume... K value would mean that there's more force compressing it from pretty much all angles, really.
Okay, and that would mean more of a change in volume.
Yeah, and meaning like a decrease in volume, because it would be pushing it in from all kind of angles.
Okay. So on test day then, would you recommend jumping straight to these questions and then looking for the answers in the passages?
Oh, yeah.
Right.
And sometimes, like, if something doesn't make sense immediately, we can continue going through the questions, and then we'll start to see some things that kind of will make it click, I suppose.
Okay.
Okay.
Also, sorry,
Yeah.
It's 7:30 almost, and I have somewhere to be.
Okay.
Is that okay?
Sure. Okay. So, okay. And I guess next time we can, continue with some of this.
Okay. Do you
Yeah.
have like a potential schedule that I should go off of right now, or should I just modify that on my own?
Oh, yeah. So I shared that spreadsheet with you. And yeah, you can take a look at that in terms of you can take a look at that. I think you can continue doing this practice test, and and see how you do, and because basically what I need to see now is just what types of questions you're getting wrong, so I know what to focus on when I'm working with you.
Okay.
And this was practice test 10. I don't think I have that. Yeah. Okay. What? All right, because I used Blueprint way before, but so yeah, you can take, or you can do a couple of these, and well, I mean, okay, when do you want to meet? How frequently do you want to meet?
What's baseline for your students? Is it a once a week thing or more frequently?
Usually twice a week. It depends on what their schedules are like, and how much I guess, material or work like we have to get done.
Oh,
But usually it's best to, like, I usually have like them do like problems or like, like a section or something like that. And like, so for instance, like this time, since we are just starting from scratch, we kind of like spent more time on each of these. But generally speaking, like when we meet next, like you will have done like a section or something like that, and you will know which ones like you got wrong, and we can and you can see if it makes sense, and if it doesn't, we can go over those. So we'll have like exactly, like we'll know exactly which ones to go over.
okay.
Yeah, and if you can send me, I don't know, it might take too long. Like the rest of this passage or something like that. That can also help me like get like kind of like a head start in terms of like how to explain certain things. But yeah, we can do something like that.
Okay, awesome. Sounds good.
Yeah. And are you good with like payment through like Venmo or Zelle or anything like that?
Yeah, Venmo's fine.
Okay. All right. So you have to be somewhere. So I'll like email you like what to do next and stuff. Okay.
Okay, awesome. Thank you.
All right. No problem. All right. Have a good one.
Okay, you too.